All right. Well, good morning, good afternoon, good evening, depending on where in the world you happen to be. My name is Christopher Harrison. I'm a senior program manager inside of Microsoft Cloud and AI. And I have a real quick confession to make. My confession is this. I do an awful lot of demos and presentations and so forth where I use JavaScript and I show off all the cool things that you can do inside of JavaScript and all the cool services that you can call and so forth and so on. But I don't write JavaScript when I'm actually writing production code. I can't remember the last time that I wrote a line of JavaScript that was geared towards production. There, I said it. I got it off my chest. I just feel better now. And the reason that I don't write JavaScript is because instead I use TypeScript. I'm a huge fan of TypeScript. I've been doing TypeScript now for probably about 3 years. And once I made the move, I never wanted to go back. Writing TypeScript feels just so much more natural. It feels like this is what JavaScript should have been. And so as a result, I always like to do whatever it is that we can when it comes to TypeScript. And today, we're very lucky, very fortunate to be joined by Daniel Rosenwasser, who is a program manager on the TypeScript team. He's here to answer all of my questions, answer all of your questions about TypeScript, about how to get started, about how to migrate projects, about where TypeScript is going, where it's come from, what it's good for, and everything else. So with that, I'm going to go ahead and bring in Daniel. I think there we go. There's the button I was looking for. Daniel, thanks again for joining us here.
Yeah, thanks for having me, Christopher. How's it going?
Good, good. How are you?
Really well. We released TypeScript 4.0 recently. It's a big weight on off of my shoulders. So I'm relieved, and it seems to be a success so far. People seem really happy about it, and I'm really happy about it too.
That's fantastic. So now you can just take vacation, take the rest of the year off, and you're done.
I did do, I mean, it wasn't a big vacation, but I did take a couple of days off, like as soon as I could after we released. I was like, all right, give me a couple of days. I don't want to think about anything anymore.
Right.
Yeah, but I mean, I still do love TypeScript. Don't get me wrong. I can't get enough of it.
Well, that's good. That's good.
Right.
So let me start with sort of the most basic of questions, which is what is TypeScript?
Well, the core premise is uh, basically it's um, our take of adding static types to JavaScript. So the idea of static types is we can tell you about mistakes you could make before you actually run your code. So as you're probably familiar, when you're running JavaScript code, you often end up with bugs that you can hit early on when you run your code, and those are syntax errors. Um, and then there's bugs that you can end up later on in your code, and some of those bugs actually fail fast, and some of them don't. So like the ones that fail fast are like accessing something off of undefined or calling undefined. Like if you run code, you've probably seen undefined is not a function in your console window at some point, and you're like scratching your head, like, what's going on? Why is this not working? Why is it like nothing drawing to the screen? Um, and there's another version of this which is just like, okay, I got undefined. Now I printed that out, and I have like, reservation undefined, or like, like so the thing is, like, JavaScript has like a lot of quirky behaviors around like just certain operations that are well defined, like the specification for JavaScript tells you this is how it should act, but like that behavior doesn't always work. Like if you multiply null by a number or something like that, you'll get nan, right? Like not a number. So
Right.
so the whole thing is like with static types, you tell us a little bit about your program, you tell us about like the shapes of things, like you tell us that this has these properties, and we'll tell you when you like mistype them, we'll tell you when something is missing, and that way we can tell you early on before you run into like these bugs, especially in production, that you're doing something wrong, right? We can warn you. um, and even more than just warning you, like once you've given us the information to tell you like what is correct code that you can write, we can help you write correct code that you can write. So like the thing that people sort of are a little bit tempted by is like, oh, catching more bugs, but then you're like, oh my gosh, the authoring experience is actually the thing that keeps you there once you've tried it, right? Like
Yeah.
you have a variable and you hit dot, and like we know what you're going to write there because we know the properties that it has, and we know that that's a method, so you can call it and we can tell you what parameters it takes, and we can tell you when you're passing the wrong, like a number instead of a string for like the ID field, or if you access a property called like name instead of first name, or vice versa, right? Um, and so like typos and like forgetting to convert values between different types at runtime, that sort of stuff is that sort of thing can be saved, or sorry, we can help catch bugs relating to that before you even run your code, before you even save your file is the cool part, because like all of this stuff with when you're typing in like VS or VS Code, we give you a little red squiggle.
Right.
um yeah, and like that red squiggle like seems scary at first, but like that's our value prop. um and knowing that you're doing the wrong thing early on gives you confidence to code well. I don't know.
Right.
So like I kind of went a little bit far into deep on this one, but I
Yeah. No, keep
yeah.
going.
Well, I mean this is a funny thing because like early on I had to figure out how to explain the benefits of this as well. And the funny part of all of this was I was able to actually find an easy way to explain this to like friends and family who were not technical at all. Because like the whole thing is those red squigglies are the value prop, right? So when people are like, "What do you do?" and so like I figured out like, oh, you know how when you mistype something in like a word processor, you get a little red squiggly, and they're like, "Yeah," and I'm like, "Oh, I do that with code, with like JavaScript and code," and they're like, "Oh, that's awesome," and like they don't even know JavaScript, but like they know the idea, like, oh, you catch typos, right?
Yeah.
Like, um, so that was a really cool thing, and like that made it really easy, like a good metaphor for also more technical people, because like a lot of JavaScript folks have never used static types, um, and that was like an unfamiliar concept for them. Uh, yeah.
Yeah. Well, let's talk a little bit about like static types and type hints that like I've been doing an awful lot with Azure functions, and I love doing Azure functions in Python. I love doing Azure functions in TypeScript, and I can do Azure functions in JavaScript. That one of the biggest challenges that I have is inside of an Azure function, you've got that handler that's going to accept whatever it is that you've set up. And what's great about doing this in TypeScript, or what's great about doing this in Python, is the fact that I can say, hey, this is what this variable is going to be. And of course, I don't get that in JavaScript. So as a result, in JavaScript, I'm so frequently just flying blind because JavaScript doesn't know what those function parameters are going to be. So let's talk a little bit about let's start with that. Let's talk a little bit about type hints and how those work, and then we'll kind of keep spinning off of that.
Sure. So the two things that a type system brings are at least like one that gets erased away the way that TypeScript does it is you have annotations and you have declarations, right? So like a declaration is like I'm telling you that a type named person exists, and a person has a name, an age, and a location. I don't know, something like that, right?
Mm-hmm.
Um, and then there's annotation, so like places that you can say like on a function, like this function takes a person, it takes a number, it takes a string as its like three parameters, right? um, and so like traditionally what you would have to do is you'd have to like just name them well enough, and maybe you would like add some JS doc comments and whatnot, and people were like super sloppy about JS doc comments, and so you would say like person object, and you're like what does this thing have, like I don't know. In fact, like you look through the npm, like so many npm packages, and like they're like, oh yeah, we have docs, and it's like object object, and you're like, all right, but like, what am I passing you? So you have to kind of piece that together from the examples. But like with types, you can like see, oh, this thing is a person object. So if you don't know what a person object is, like maybe you give it an object literal, and like you start typing and it fills in all the properties for you, right? And you basically just write a colon after the parameter name and the type that you want, and like that's a tool for TypeScript to understand, like this is the thing that it's going to take. And then the tooling lights up as well. So like that gives you a form of documentation. Sorry, it's a little hard to like explain
No,
in my
yeah.
mind while we don't have a visual example, but but the idea is like all you need to do is say like this parameter has a type, and the way that you do that is you write like colon after that, and then you add a type annotation, right? So that's like a name of a type. It might be like the keyword number. It might be the keyword string. Yeah.
So what I can do is I can create a function and then have my parameters, and my first parameter could be name, and I could say name colon string, and that would then identify that that's going to be a string. Or I could say something that's going to be more complex. So you mentioned like there could be a person type, so maybe buyer colon person, and have that.
Right. That's a way less long-winded way of saying what I was trying to like. It's the I mean, we could do examples, but I think it'll just be easier this way. Yes, like you can basically just say the key syntax in TypeScript is like colon and then whatever a type is. And
Right.
a type is like the string type, and that's any string, like anything in quotes. The number type, anything like that starts with number characters, and then Boolean, which is either true or false. And it's really lightweight. Like the whole thing is not to make a completely new syntax in JavaScript. It's basically to build off of JavaScript and add like as little as possible while still giving you value in type checking, right? Like get a
Right.
good authoring experience, but like one that doesn't hijack the language and just like make it its own thing, right? Um,
Yeah. And those type hints go away because that with TypeScript, obviously, I'm not running the TypeScript. It's going to transpile down into JavaScript, right?
yep, yep.
So, and then all those type hints go away.
Exactly. So it's all erased. That's the key thing. We have a couple of constructs from like the old days, and that's from like the era where I think TypeScript was like figuring out its existential niche. Like, what is, it was like a
Having a midlife crisis.
yeah, like, or like first year life crisis. Like the whole thing was, if you go back a couple of years in the JavaScript ecosystem, you have this sort of you had this compiler transpiler like sort of renaissance, like everything compiled to JavaScript. It's like if you got anything, I'll turn it into like something that can be compiled into JavaScript, was like sort of a mantra. And so CoffeeScript was a big thing, and CoffeeScript was trying to like make its own language with like all these snazzy new constructs that were not part of JavaScript. um, so it was not just like a difference in syntax. And like early on, we were like, oh, that seems cool and useful. Like that'll probably land in JavaScript itself. We should do that. And so like we have a couple of these things, but like most of the time you don't even need to use them nowadays. People kind of forgot about a lot of it, and people just use a modern form of JavaScript nowadays with types that are just all arrays, and that's the way most people use TypeScript nowadays, and it works really well. Like,
Yeah.
yeah.
So let me, because you touched on CoffeeScript real quick, and there's a couple of questions that are backing up here, and I'm going to get to them in a second. So I just want to make sure anybody who's watching and has asked questions like, "Are you ever going to get them?" I am, but I want to ask you this real quick because this is a question that I get quite frequently, which is why use TypeScript when maybe I could use, say, ECMAScript and a really good linter instead?
Well, so so I guess the question is not so much, is it more about just like using the latest and greatest JavaScript features, or is it just like using a linter? I guess let's break down that question, right?
Yeah.
Um, so one thing about TypeScript is that we try to follow ECMAScript, which is just the standardized name of JavaScript.
Right.
We try to follow all the latest features, and we do this process called compilation or transpilation, depending on who you ask, to like take some of those features and bring them. We call it down leveling. We take those features and make them run in older browsers, right? So like, nowadays it's less of a concern because like the newest version of Edge, Firefox, Chrome, whatever, Safari, like they're all pretty modern. Like as soon as something gets standardized, like a lot of them just like immediately implemented, and that's great. But there's a bunch of mobile browsers on Android that like still don't get updated. There's still like people who still need to worry about certain versions of IE. Right? But like this was
Yeah.
even worse problem back then. And so like overall, TypeScript doesn't necessarily like, we're trying to make sure that you can use those ECMAScript features, right? But that's not necessary. But the ECMAScript features make way for a typed experience. Like they gave us structure over the years so that we could get a better editing experience, better way of modularizing code, not having to worry about conflicts. And once we had that, we could also build, a good typing system on top of all of that, right? Like you have
Right.
classes, you have a way to type classes, you have modules, you have a way to like structure and import and like make sure that all works. And then what types do is specifically a type checker does a little bit more. A type checker can deeply analyze your program, right? Like most linters nowadays for JavaScript go a file at a time, and they look more at syntax. They look more at like how you've written your code, rather than understanding like this file imported that from over there, and it doesn't have that property when you try to
Hmm.
like access it, right? So like we have a more complete version of the world. We have a complete view of the world, whereas a linter could in theory like get that information too, but at that point you're like building a linter that is integrated in a type checker. And ESLint has ways to integrate with TypeScript. Like there are ways to write semantic rules that use TypeScript type information. Um, but overall, like you have to ask yourselves, what is the sort of thing that I'm linting for, right? So like there's style lints, which a lot of people have just said like let the formatter run it, I don't care. And TypeScript tries not to like get in that business. Um, there's other like common mistakes, and there's like sort of a balancing act of like how much of this is the responsibility of the linter and how much of it is the responsibility of the type checker. There's no clear answer for that, but what we try to do is like what is objectively going to save people time all the time, or like I mean there's no objective way, but like what gives us an overwhelming feeling that this is a net positive for all TypeScript users.
Right.
um, and a linter is like more like we would typically say if we're not really sure about a specific type of check, like to catch an error, we would typically say write a lint rule for that, because we can't apply that to everybody in the world, and we don't want to be responsible for like a compiler flag for like controlling that type checking behavior. um, so we try not to get into that business too much. um,
So basically, what I'm hearing is like a good linting setup will catch a lot of the potential issues. But I like that phrase that you use, that a linter's not going to have a full picture of the world. That if there's something
right.
that's missing in a file like a property, the linter isn't going to catch that. And then TypeScript then also gives you that typing, so I can say, hey, this is supposed to be a string, whereas a linter's not going to be able to catch that. Now, Plop Plop TV asks the question, is it a good idea to use a linter on your TypeScript code?
Yeah, I mean there's definitely I would say yes.
Okay.
I would generally say don't go overboard on certain things. Like I personally do not like the default rule set for most linters, or at least like the things that people say recommended, I tend to disagree with personally. So like I don't like to over focus on these things. I don't like to say like yes, you should always use a linter, because like it kind of feels a little bit I want you to think about the decision a little bit of like how, why should you inflict pain on yourself or your teammates? Um, Because like this is an argument. These are arguments that like teams always end up like fighting about, and it's like, oh, should we force every function to be you know declared before the variables that it uses? It's like I don't like that, so I'm not going to recommend that to anybody. Um, that said, um, I think like you need to think about what makes sense. What types of errors do you catch typically? And like spend like 20 minutes going through a couple of rules that are built in and then figure out like what does your team keep running into, right? You know, but I won't say like turn every rule on because like
Okay.
yeah, that's a little bit too much.
I gotcha.
Yeah.
I'm going to go a little bit backwards on the questions here. And Nick on 1984 asks, where does one run TypeScript? Front end, back end,
Uh,
all the
TypeScript.
above?
Yeah, all of the above. So the simple answer is TypeScript runs anywhere JavaScript runs.
Yep.
So if you run front end JavaScript code, like you're writing a website, you can write TypeScript in place of that. And if you're writing Node code, there's a ton of ways to do that too. And so you can write TypeScript with your functions, with like Express, with React or Angular or Vue or whatever you want. Um, and that was sort of the thing, right? Like we never wanted to be like boxed into one specific thing because like JavaScript is very multi-paradigm or like cross-platform or whatever you want to call it. Like you could write JavaScript that however you want on any platform that you want. And so like TypeScript doesn't have to model like all of the things in the world, but it is supposed to fit into the same places JavaScript can fit into, right? Um, like there's no way a type system can model everything in the world unless you just say like any, which is the type that allows anything to happen. It's like if you use any in TypeScript, it's like going back to JavaScript. But like you want to be useful, and so like with front end code, you can just compile and you can use a bundler just like you do with your regular JavaScript code. You can use like any other loading tool. You can use standard modules. With Node, you can also use the compiling cycle. You can use tools like TS Node. There's even a new runtime out there called Dino, and that actually runs TypeScript directly. Um, there's a couple of things I'm not totally sure about how they're going to go long term with that, but it is kind of like exciting to see like experimentation in that field. So,
Yeah.
yeah.
Let's. So we're getting a lot of great questions here. So here's another great question. So Nick once again or has another question here, which is does it slow the process down? And I want to ask this in two ways. Number one is that transcompilation, because it's the JavaScript that's going to get run. So how long is that process from converting or transpiling or whatever word it is that you want to use from TypeScript down into JavaScript? How long does that typically take? And the second question is there a performance hit in that emitted JavaScript?
So those are both really good questions. I'll answer the second one first.
Okay.
The answer to the second is no.
Okay.
So there's no performance hit. Now there's certain. I mean, you have to ask. We have to be specific about what we mean. Like when we're talking about taking the TypeScript and like stripping it out to its equivalent ECMAScript target. Like if we're not making any modifications to that, that's mostly just like reprinting it out while stripping out the types. No runtime impact.
So what you're telling me is if my application runs slowly, it's my fault.
Yeah,
Okay.
exactly. Yeah.
I'm good with that.
but I mean if you're targeting an older JavaScript version, like let's say you're trying to use async await on ES5, we've got to generate a bunch of scaffolding to make that happen because like internal to what your engine does is it actually turns that into a state machine. If you don't have an engine that turns that into a state machine, TypeScript has to turn your code into a state machine, which means like we're gonna it can blow your code up depending on how big that function is. So you have to be a little cognizant of it, but luckily you can give different browsers different versions of your code. So that I think that's the answer there. You shouldn't be afraid of like TypeScript emit for the most part.
Okay.
And the second question, is like, how long does it take to compile? Now, I think for most people, this is part of what TypeScript has to fight against, because like you're are in a sense like not really our competition, but like the alternative to TypeScript is you don't do type checking, you don't write in TypeScript. You just run your code directly on the engine, and like now you have this extra process in between, and that kind of like stinks. That's like a lot of people don't like that. So we try our best to make sure that you can get a fast compilation pipeline,
Mhm.
um, by doing a lot of different tricks. And there's a lot of optimizations that go into that pipeline. So first of all, like if you're already going to be using something like Webpack or Rollup to bundle, you already have like some sort of build pipeline. And so like it's kind of easy to like, or it kind of feels natural to get TypeScript into that pipeline, because like there's no intermediate step. Um, there's ways of doing a full program compilation, and then we can like do an incremental compilation on watch mode. So like we only change the things that need to be changed on watch mode. We only check the things that need to be changed in watch mode. Um, we have a new mode that's like uh, can be incremental from disk. So like we'll check what needs to be checked between like a cold boot of like of the TypeScript compiler or like your bundler. Um, and then there's like a bunch of ways to do what's called isolated emit in a separate process. So like we literally don't even need to type check before you emit, so that you can run your code. So like you type check on one thread and you like emit on another process, and like the whole thing happens in parallel, and like you can actually run your code before you get your type errors. But for some people, like that's a worthwhile proposition, because you can prototype faster and you can just like keep playing, and then you'll see like a broken page and you're like, what the heck happened? You check back in your terminal, like, oh, everything's broken. But the thing is, like, you see the errors ahead of time because like it's in your editor. You see the red squiggles
Mhm.
as you type. So that's not as bad for people. Um, and actually, like, there's an entire wiki page on performance. So, like, the reason I'm giving you so much detail here is because, like, we've been working with a lot of like really big customers on really big code bases, and like most people never have to worry about this sort of thing,
Okay.
right? That's the good news. If you're at a certain scale and like you've built a massive monorepo without like any sort of separation between your components, um, there's a little bit of tech debt that you need to do, and then like once you can do that, like you've got faster builds. Um, so like just if I go into too much detail, it's because like I have my hands in like every part of the pie, trying to like talk to our users, trying to figure out like what's wrong, and like I'm hypersensitive to like every
Yeah.
sort of feedback. And like you tell me, oh, it's really slow to compile TypeScript, I get like really concerned, and I try to like figure out what we can do to make that better. Um, so like this has been a thing that I've like been working with a lot of different customers on to like make things faster. Um, in fact, that's like anyway, we can
Yeah.
talk about it a little later, but like that's one of the editor things that we worked on for 4.0 was like making sure that you could open up your editor and get responsiveness like as fast as possible too.
I dig it. No, I absolutely dig it. So, I guess sort of along those lines, and a couple of people now have asked this question that we have Hamzala Kindi, forgive me if I'm mispronouncing a name, and then TriCAPTCHA, which is basically, is there a circumstance in which you would recommend writing JavaScript instead of TypeScript? Now, of course, this is being asked to a couple of TypeScript people, so
So
we
this
might be
is
biased, but I'll be curious your answer here.
um yeah, actually this is something I wanted to talk about when you had mentioned for like the Azure functions, or like when you have to go back to JavaScript, like you're like missing the types a little bit, right?
Yeah,
And so my personal thing is I kind of get it with the iteration cycle when you're writing with Node code, because like with the browser, you do typically have like a bundler now. Like I don't know if that's always going to be I don't think that's always going to be the case necessarily, but like right now, um, you always typically have a bundler, and that's always part of the step. And so like you just get it you get a build step for free. Um, when I write Node code and it's only going to be like 2 or 3 files, I actually write in JavaScript, and
interesting.
And not just that, the thing that we have built into TypeScript, or yeah, the built thing we have built into TypeScript is a way to like actually understand JavaScript code. So I don't know if you're familiar with this feature that we added called check.js, but you can actually write JavaScript code and get type checking, errors and checks in your code. And the way that you can do annotations, like in TypeScript, like I said, you use like a colon after the identifier. You can use JS doc comments to actually annotate and document your code in your project, and that's super nice because even so just to give you context on like how this came about, this was this all started when we were like realizing that every single time we needed to add like JavaScript functionality to our editors, we had to like add like new ECMAScript features, all that stuff, and then we realized like, oh, the TypeScript team is doing the same stuff, and it has all these like type declaration files to like document the entire world of like the JavaScript ecosystem. What if we built the JavaScript experience off of TypeScript in Visual Studio and Visual Studio Code?
Mhm.
And so then you started getting autocomplete in our editors powered by TypeScript for JavaScript code. And then this was like a really cool thing when we realized like, oh, well, what if you could have like a mixed mode TypeScript and JavaScript project? Like that seems obvious, right? Like you have that to migrate. And then we said, oh, well, one of the things that we needed was like a way to actually document your JavaScript code so that you could get better editor support. And we saw that like the ecosystem was like roughly, using JS doc. Like I said, it's like really, really sloppy, but it
Mhm.
was something. Like if you said you had a number, you had a number and we could give you like the methods on a number. Or like if you had an array, you had methods on an array. Didn't matter. Um, and then we said, what if we use that same logic to actually check your program? And so every time I write a Node project nowadays, I use check.js. All you've got to do is add like a / at ts-check comment at the top of your JavaScript file in our editors or like in a JavaScript project file in a project, and you get it for free. If you actually look on our website for like the type checking JavaScript section, we document all of this stuff there, and it's super handy. And it means you don't have to have a compilation pipeline. And for 3 files, like you can hit the ground running on iteration without ever compiling, which is cool. I think once you have like more than 10 files, like you might as well just like get compilation into the pipeline. Um, the syntax for JSDoc is not my favorite. But like it beats like figuring out how to like get the whole project, workflow working, right? I think that's kind of nice.
Yeah.
And
No,
for
I
some
love
people
that.
like writing tests too. Yeah, sorry.
Yeah.
I think like if you were ever a little bit afraid of like, oh, how am I going to get this set up? Like this is also a good opportunity to like get your toes wet on like, do you like type checking, right? Because type checking is sort of separate from the emit depending on the language you pick. Like transforming your code is separate from type checking. And so like if the syntax is just JS talk, we can like look at that and we can see number, object, whatever, and do a good job there. So that's my answer. And then maybe you don't care about like type checking that much, but like even in our config files, we add a TS check comment and it's handy.
Okay.
The most
Let's
handy there.
well let's keep spinning on this. So my next question is, if I'm already a JavaScript developer, let's talk about the skills upgrade first. How would you recommend to a JavaScript developer they get in and start learning TypeScript and like just getting used to that style?
Um, so we actually really recently also launched like newer docs on TypeScript as well. So our website's updated, and like I think that just reading through the basics is a good way to get started on like the intuition behind like how do you use this thing. Um, and then we've got a playground as well. If you go to our website, we have like this little section that says play, and you can just type in TypeScript code and see what it gets emitted to and see like what the errors feel like. And it actually feels like the editor that you'd use for writing TypeScript. Like it's actually this thing called Monaco, which is the thing that powers VS Code. It's a little editor component, and so
Mhm.
like as you type, you get red squiggles and you get auto completion, and you can go to definition and like hover over things, and it all just works, which is like kind of the amazing part of JavaScript is like if you build your thing in JavaScript, it works in the browser like a charm. Um, and so like I think the playground is a great way to try. And did you mention migration before in your question as well?
Well, that was actually going to be the next question. So let's talk a little bit about that. Is if I've got a JavaScript project, how can I migrate that? Do I even want to migrate that into TypeScript? What's my what's an approach there?
Yeah, and I think that's like a question we're always trying to get better at. But generally speaking, we kind of recommend this like you can think of it sort of as this like gradually, this gradually typed slope of like you start off with like an all JS project, right?
Mhm.
And you kind of have two paths. You can either go one by one, switching each JS file to like a TS file, which is like the TypeScript extension, or TSX if you're using React. Um, and so you go one by one and do that, and the alternative is you can start adding type checking to each file with TS check with check.js. So you add like this TS check comment to the top of your file every single time, and then you go one file at a time, and you can add JS stock incrementally. Like you can start adding JS stock to your function parameters and your method parameters, right? Actually, the thing is like the only things that you typically need to annotate are parameter types. The rest of it we can do inference, which is a little different from a lot of other type systems where you have to like say what the return type is. You have to say what a lot of different things are. We can often infer from like just what you write on the right hand side of the equals. Um, and then once you switch, once you have something that's well typed, you can start renaming your files to .ts as well, and you can start like we start giving you like little refactorings in your editor to say like, oh, can we infer the types from the usage? So like if you call this function a lot of times, we can figure out, oh, it's called with a number, and a string. So we'll just like add the JS comment for you, and or the type annotation. And then when you switch to TypeScript, we can say, oh, you have some JS stock. We can like add that into the type annotation. So like, it kind of depends on what your team feels most comfortable with. Like you can start off with like just JS doc checking, and then like you never have to like add a compilation step at all. Um, and then you can be like, oh, actually, this was worthwhile. Like we should start switching to TypeScript because like I'm starting to hate JS doc. Um, and then the last thing for migrating a project is adding strict checking. Um, so we have like strict null checks, which are like making sure that you handle null and undefined correctly. We have something called no implicit any. Like I mentioned earlier, any is the type that lets you pretty much do anything you want.
Mhm.
And you want to avoid that. And when TypeScript can't figure out a type, it'll infer any instead. And so like no implicit any will tell you that when that happens. Um, and we have like one Uber flag called dash dash strict, and that'll just like apply all the things that we think the best, you know, the most well-typed TypeScript code should have turned on and checked. And so if you're starting a new project, you always want that on. But if you've got existing code, that's like not always feasible to start out with. But you get a lot of returns from it. Like you get a lot of great bug fixes. And if you talk to companies that have made the migration, um, they're super happy about like adding more strictness if they can. And if you look at companies that have like speculated on it, like I think it's been quoted a lot, but like um, Bree Bunge at Airbnb, she had given like this report where they looked retrospectively at all their bugs and found like so many of these could have been caught with a type checker, right? Um, and then at Microsoft Research, we had like this report where like TypeScript under strict mode and like another type checker called Flow, both caught roughly 15% of bugs like looking back at some GitHub
Mm.
issues and the edits that were associated. Like a type checker could have caught a lot, 15% of these. Um,
That's a good percentage.
it's a good percentage, right? And you get these things for free because like you're catching these as you type a lot. I mean, there's overhead. You have to think about your types, but like that pays off in the long run. It's a little
Mhm.
bit of planning for like long-term gain, right? I think it's worth it.
No, and I agree. I think it's worth it as well. The number of times that TypeScript will catch all of those bugs, it's innumerable for me, and especially because and I know I'm not alone in this, is that we all have sort of our own little quirks, our own little things that we wind up forgetting. Like the number of times that I've written a method and then forgot to return a value at the end is innumerable. And it drives me crazy to do that in JavaScript, because then all of a sudden I get is, something is undefined, which means either A, it didn't return a value, or B, maybe I just, I have a typo that I could have misnamed it, or that, I could have misnamed it when I called it, I could have misnamed it when I created it. Like there's a million different things that could have caused that to be undefined. So
and that's
it's
strictness check that we get too, right? That's a thing that like we catch when you do turn on strictness checks.
Yeah.
So I mean, I'm all about stricter checking. If you can get it, you don't always have to be you don't have to feel guilty if you're not using strict mode. Is one thing I try to tell the community, but it is so worth it if you can.
And I like that migration path that you mentioned about, starting with that type checking in JavaScript and adding JS doc. Because even if you decide, hey, you know what, we don't like this, well, the advantage is we're now at least going to have better docs in our code, and that's always going to be a win. And then if you decide, hey, this is kind of cool, then you can continue to grow and then continue to build towards that strict. I love that flow.
Yeah. We have someone on our team, the person on our team who like mostly works on this, did like a blog post that was something, I don't know if he titled this, I don't know if he actually titled this and we published it on the blog, but it was like how to convert to TypeScript without your team realizing. Because like a lot of people say like I can't get buy-in from my team that this is a good thing. Because people are like, it just works, don't touch it. And like totally understand that, right? Like, but at the very least, this gives you a great incremental path. And like, what are you going to do at your teammate? Like, don't write comments. Like, what? That seems a little heavy-handed or weird. I wouldn't join that team. But yeah, and then at the very least, it's not just comments; it's also editor support. So like, even if you're not checking, we still give you those completions because it's still types under the hood. It's still TypeScript. Being like, I actually know what you wrote. Let me give you all the methods there, right?
Yeah.
I think,
No, I love it. I want to go back. So this has been a hangout here, and John Petercroft, if you're still connected, thank you for your patience here. But you asked a question quite a while ago about React and TypeScript, and you had mentioned that real quick. So if I am a React developer, is writing React in JavaScript that much easier than trying to do it in JavaScript and JSX files?
Do you mean if it's easier in TypeScript than JavaScript?
Yes. Yeah.
Okay. I mean, okay. This is sort of there's no right answer except for because you're asking the TypeScript PM. Yes, like I think it's better to write in TypeScript. I think the unfortunate thing is, a lot of what React does is it does like the community does a lot of these like slicing and dicing of like properties and objects and like a lot of these things with like higher order components and I'm not saying like I'm not bashing the community. I'm saying like there's a lot of these things that many type systems cannot deal with, and TypeScript does like a champ, but it is super hard when something goes wrong because what you're doing is you're like creating this ultra complicated type that like is hard to express in any system. And so things are a lot better with hooks right now, and they got a lot better with render functions and a lot better with hooks. And like I don't even write React, but I know these things. But that's the thing. Like these things got like significantly easier because there was less of the slicing and dicing. It relies more on hooks mechanisms or whatever. I think the thing that TypeScript really helps with is like because you're telling us the types of your props on every component, like we'll give you autocomplete in your tags. You write the tag, we know what's missing, we know what you need to insert, we know what's optional, we know it's supposed to be a string, but you pass a number. We know when children is supposed to be present, and you know, like for a lot of people, it's a winning combination, right? Like it I think if you look at a lot of surveys, more and more React users are like, oh my gosh, TypeScript is amazing. I'm going to use every React TypeScript. Like I mentioned, it falls out because most React users need to compile out the JSX anyway. So like you might
Right.
as well get rid of your types too, right? Now, again, like I just want to throw out like TypeScript works great on every library, and if it doesn't, like we try to do a little bit better there as well. So we try to be like the Switzerland of frameworks, so to speak.
I appreciate that. So Zarius asked a question here. Does all the typecasting and strip typing happening in Oh, okay. So it was, sorry, I had to figure out what the question was. So yeah, so Xeris asked the question: does everything that you're doing with typecasting and strict typing and so forth, does that give you better performance in your running JavaScript, or is it just to control the chaos that writing vanilla JavaScript provides?
So it's not for performance. A lot of people speculate that like, oh, you know, if TypeScript was built into the browser, yada yada yada, faster, because types equals faster, right? Like the reason
Right.
JavaScript is slow is because it's, you know, it doesn't have types, and there's a lot of nuance there. But the short answer to that is for most code you won't get like a significant like perf boost or anything like that. But the thing is, when you write types out, you become more aware of like why something performs better than one thing or another. So I don't know if you want to get into engine specifics, but typically like what happens is engines are able to use you know profiling data from past instances of an operation to figure out like what is the most efficient code to generate to perform this operation, right? Like there's an abstract operation for like getting a property on in JavaScript. Um, if you know that this property always has like was created with like a name, an age, and a location, you can have the code generated in the JIT in the JavaScript engine. Say the name property is like right here on the object, and it'll always be really fast. Um, Now, if you have multiple types, like it's a person or it's like a dog or whatever, and that they both have names, but like because that's two different things created in a different order with different types. Um, that won't necessarily perform as well, but you'll see a little bit that like, oh, the person used a union type there, right? A union type is a way of saying like I have one type or another type in TypeScript. It's something that like if you've ever been like, oh, you know, a language like Java is so rigid, I have to like inherit from this thing and create a like an inheritance hierarchy. No, in Java, in TypeScript, you just say it's A or B, and then like you figure out a way to like differentiate between them. But your engine has to do the same differentiation. So it's a little bit slower. The thing is, for most people, who cares? Like most of your applications are not like these CPU bound things. Like TypeScript itself is pretty CPU bound. Your application is often slow because like it's hitting the DOM in like a bad way, because you're hanging the UI thread in some like weird way if you are doing CPU bound work. Um, so I don't necessarily. I would say like yeah, I mean, some people have said like using TypeScript has made it easier to like write performant code for that reason because
Mm-hmm.
like they're more aware of it. Like you know, Tom, Dale, and Yehuda Katz and others worked on this Glimmer engine for Ember, and they were big fans of TypeScript when they first started using it because they were like, oh, uh, doing this has made us more cognizant of the sorts of types that will be in the VM. And Glimmer does need to be CPU bound, but that's more for a library author than it is for most application developers, I'd say. Um, Hopefully that answers the question.
No, it definitely answers the question. So yeah, and besides, like I I always like to say this, and I always like to make sure that I highlight the fact that I'm mostly exaggerating. I'm being very glib when I say this, but I still think that there's a fair amount of truth there. Is that, on every project that I've ever worked on, with the exception of one, um, goal A was time to market, goal B was performance. And the thing that I really love about TypeScript is that I can hit goal A. I can get to market faster because I'm a better developer when I'm using TypeScript. And then, as far as the performance, especially if it's server, we'll just throw more CPUs and throw more RAM at it, and solve the problem that way. And again, I'm being glib, and I'm partly joking, but I'm also partly being serious that, on most projects, it's time to market. That's really what we're being measured against, and performance is. Performance matters, but a lot of times performance winds up being secondary to time to market.
I mean, we at Microsoft have some products that are like that too, but they're getting
Yeah.
better. And so like I mean, I won't name things, but like they got to market and now they're doing better. And so you can improve them, and you can, as long as you don't have like an API yet, you can often like, optimize
Yeah.
more and more.
Yeah.
Um, but what I will say is, like, if you are interested in like writing performant code in general, like I would just spend some time with like internals of like just computers in general, and then like if you're really into that, like do it from a hobbyist point of view, but like don't be a little, don't over prematurely optimize in that
Yes.
case, right? Like I think it's important to, especially now, I think it's important to write good code, especially since like I have so many apps running my CPU crazy, um, and that's not great. But at the same time, like I don't know, I think that there's other ways to achieve that
Yeah,
too.
and the other big thing is, compilers are so smart. If you're almost always, if you're writing good code, it's also going to be the best performant code. Again, general rule, but
Yeah.
yeah.
Yeah, I mean, it really depends, and like I don't know. I don't know how to generalize this, and I feel like if I say the wrong thing, like people will get mad at
Yeah,
me.
yeah, yeah.
But like
Exactly.
I think I understand the fundamentals, and like, okay, are you looping through like 1,000 elements at a time? Like go do
Right.
that. Okay. But yeah, like ge- like find a good style that has become more canonical. Like the lucky part is, as opposed to like other languages where like you do try to be very cute about your style, JavaScript already kind of puts you in a place where like you do some naturally like intuitive operations that are like not too slow in their performance, and you're like, okay, this
Right.
just works. And it's like how, and it's just performing on a modern CPU too.
Yeah.
um
Yeah.
yeah, I truly geek out on like the lower level stuff too, which is tough for me. So like I really want to get into it, but like it's not worth it.
I love it. So let me ask you this question. We've got just a couple of minutes left here. Is about the future of JavaScript, and where. Sorry, of JavaScript, the future of TypeScript and where TypeScript is going. Because obviously, you had mentioned at the start of all of this that TypeScript 4 just dropped. So, what's new in there, and where's TypeScript going in the future?
So so really quick aside, you mentioned what's the future of JavaScript. I mean, I'm not specifically like trying to get at anything, but I will say like we also this is a question a lot of people say is like, what if JavaScript ever has types or something like
Yeah.
that? And well, so with that one, I don't think there's any near-term plans for something like that. But people are often like, why would I use TypeScript if like in the future there might be a totally incompatible thing? But we like the TypeScript team is on TC39, which is the standards committee. I'm one of the representatives there, and so we give our input of like what works, what doesn't, what do users want, what's going to be an issue. Um, and like we truly want to make sure that whatever gets proposed or anything like that doesn't throw like the existing community, which is pretty massive at this point, under the bus. So we're very cognizant of that. But when it comes to the future of TypeScript, I think like the things that are at the forefront of my mind, one is we're always trying to be expressive, more expressive, trying to make it so that um, you know you were already writing JavaScript code, and the idea was when you wanted types, you had to like change the way that you wrote to satisfy a type checker. That's like every type checker has to save you from a couple of mistakes. So we were trying to make the type tester a little bit smarter so that you can convey your intent of things, and you can just write JavaScript code the way you wanted without the type checker getting in your way. Um, and the hard part of doing that is making sure that like there's not too much work and bending over to express that thing to the type system. So it has to be like cognitively light. Um, that said, we're adding a thing called recursive conditional types. um, but the idea there is like a library author uses this really high level feature so that they can do these arbitrary sort of like type operations. So like you can write this thing that like flattens a list of lists to like the bottommost array type or like element type. So you can write like a flattened type in TypeScript that just gets like list of lists and gets you like number at the very end of that, because the bottommost list was numbers. Um, so that's like a pretty powerful like type system feature coming in 4.1. Um, one thing that we are always focusing on is like better error messages, because like when we add these like super sophisticated sort of things, we built up like this UX stat, which is like, okay, now how do people think about these things? We need to give better error messages so that others can reason about this. And then we're also trying to make TypeScript faster, leaner, so improve the product, the speed, um, productivity, so like better editor features, and on top of all that, like we're trying to make the onboarding process easier. So like how to get started, the website, the docs like that. I think I hit all those just before the
Yep.
hour mark, or maybe 2 seconds after.
No, that's perfect.
But I mean, TypeScript has grown in its scope for a while now, and so like getting started experience, productivity, compiler and type checker, speed, like things like that. And then there's like community, and like there's so many things that like those are high level points, but there's a lot of other stuff as well that we have to kind of consider. And like so we typically have roadmaps that if you want to ever take a look at these, like we document what's coming in the next 6 months. The current one is not posted yet because life happens and like work happens. But it's largely they don't change drastically from like 6 months to another, because we're pretty consistent in what we do. And then we have iteration plans that cover what we're doing for the next 3 months. So like TypeScript 4.1 is coming out soon, and our iteration plan is already publicly posted. And it talks about recursive conditionals, talks about like some new stuff for like understanding different types of doc comments coming up, some other productivity features, and just more expressivity. So um, hopefully that is helpful. I encourage you
Yeah.
to like learn more about like what we're planning and get involved if you're curious, and learn more at the website if you want to learn more about TypeScript.
And that
Yeah,
website is
TypeScriptling.org.
perfect.
Yeah,
All right. Well, Daniel, thank you so much for taking the time to come out and talk about TypeScript. This has been at least a lot of fun for me. I hope everybody else had a good time as well. So it was great to get to chat about TypeScript. So thank you so very much for coming out.
yeah,
So thank you.
yeah. Thanks for having me. This has been actually a lot of fun. So I really enjoyed it, and I enjoyed
Excellent.
answering questions too.
That's great. Thank you. And I do want to mention real quick to all of our viewers that all of this is going to be posted out on youtube.com/Microsoft Reactor. So you can go back and watch all of this a little bit later. And I also want to highlight the fact that tomorrow, all time specific, at 4 p.m., we're going to have Gabrielle Crevacore, who's one of my favorite humans on the planet, doing TypeScript demos. So if you've not seen TypeScript and you want to see the syntax, come watch Gabrielle. So we'll see you all tomorrow. Thanks again, and have a good night. Bye.
Take care.